Okay. Okay, so on this stream, I want to create a basic puzzle app. Many years ago, I saw a book called Familiar Butterflies of North America, and ever since then, I've had a look through it, but there's so many different names of butterflies, and I can't hold them all in my head at once. So I want to create something that will enable me to memorize them, so that when spring comes around, when I'm hiking and I actually see some of these butterflies in the forest, I actually know what they are. Instead of just saying like that's a butterfly, I can go, I could say this is a like Milbert's tortoiseshell or whatever. Instead of using some existing infrastructure to create a quiz like this, like some website, I want to create something from scratch on my own in Zig for two reasons. One, because if I use an existing website, I have no assurance that the website will exist in several years' time. I might make something and then in 10 years' time I can't access it anymore because the website has been sold to some company that has closed it down. And I also think Zig is a really exciting language. I could do this in Odin. I know Odin particularly well, but I think that Zig's sort of model is more appealing and is going to stick around longer. Okay, so I'll be using raylib. And in particular, instead of creating my own bindings from scratch, I'm going to use some existing raylib bindings, namely these ones here. So I'll just begin by kind of cloning this. So let's see. So let's create a new folder for this project. So we can call this, say, like butterfly quiz. And then let's create a folder for to copy this raylib repo in. Do git clone here. Okay, that's been loaded. Once you've cloned this, if you go through the instructions here, you can build some of these basic raylib examples quite easily. Namely, let's just try this Zig build basic window. It would take, when I did this last time, it took a bit of a while for it to download stuff, compile it, all of that. But once this is okay, hurrah, it's working here. A bit small, but hey, better than nothing. So I think the easiest way to start using this is to actually just copy the entire repo into our project. Okay. So you can see this is here. And now let's clone this basic window example to begin our project with. Okay, so let's see. So let's create our main Zig file. I'll be using Emacs throughout this. I despise bulky editors like Visual Studio Code. I can't deal with it. So if we go to examples core, this is where we can find the basic window example. So we can just copy this. Okay. So let's save this to a buffer. So E, get E. Okay. And now we'll need to set up the build options. Luckily, this project kind of has a script that's fairly easy to read to figure out how to do it. For whatever reason on my computer, when I tried running this build script, it failed, which kind of figures considering this is a shell script and not like a Zig-related thing. But that's okay. It's very easy to read these instructions and figure out what we need to do. So yeah, in this first, if we were to run this build script and it were to work, these first couple of lines just say, was there like a name passed into this? If so, kind of name it. We can ignore that. Then the next part, make a directory with that name. Again, we can ignore that. Okay, in this part here, we're building the script is building the build script for Zig. So let's go ahead and create that. And then we can see that in these portions here, it's then outputting this to a console and then writing it to build.zig. So if we just copy this over, in theory, after we modify it, it should work. A lot of this is totally redundant. You can see this part here says if the target OS is in Scripton. I have no intention at this stage of putting this on the web. This is just for me, so let's just get rid of that. There's all of these project names that appear as well. we can just call this what we want the executable to be. So why don't I just call this butterfly quiz, and then the path to this, the path to the file we're going to compile, just call it main.zig. Likewise here, if we want to call our build script with run, let's just give a description of it. We can just say this is going to be calling run the quiz, and this looks okay at this stage. Okay, so let's just try it. We can do zig build build run, and then this will compile and then run the basic window option. Let's try this again. Okay, we're getting an error here. No dependency names raylib and zig.zon. Okay. I stopped here, but if we continue looking down here, we'll see that in addition to copying the basic window example, this build script has also copied the build.zig.zon file, so we should also copy that into the project. So it's build.zig.zon, and then let's go and find this within here. Here it is. Okay, now we've copied that over. Let's try it again. Thank you, LLVM. Compiling, doing its thing. Ta-da, great. And now we have our first window. And just to show now that we now can have control over this window, let's modify it a bit. Let's switch to our update. Let's switch to here. Let's just make the background black instead of light, the text white instead of black, and let's make the background black instead of white. Let's kill this. If we compile and run it again, indeed we've got these changes. This window is too small for me, so let's just make this bigger while we can. My screen is also 144 frames a second, so I'm going to do that. I know what those commands do, so we can ignore those. So let's just make this 820 by 920p. So at least it's like a quarter of my screen. Okay, great. Okay, so now the actual fun development part begins, not all of this pulling binding stuff. I think in later videos and later throughout the year, I'll end up writing my own bindings. That is if I'm not at that stage just interested in learning DirectX and doing stuff that way. I've previously done stuff with OpenGL, but I found that that takes doing that from scratch takes a while to set up, and just running with some pre-existing bindings like raylib kind of work well. But yeah, we'll see how that goes. So get rid of this. Get rid of this. Okay. I'm just going to make sure I can. If anyone wants to like ask any questions, I can actually respond to them. So I'm just breaking out the chat stuff on my iPad. Okay. That's working again. Okay. Great. Okay. Okay. But back to raw stuff. Okay. So let's So I think I want the quiz to work as follows. There's going to be a main image with a picture of an animal, in this case some butterflies, and then there'll just be some like names, like a common name of it, perhaps it's like Latin name, something like that, and basically it's just a way for me to, like help remember what these names are. So this would just require us drawing some rectangles with text for the names, getting an image to the screen, and doing some mouse interactivity. So let's kind of just start by drawing some rectangles on the screen. Okay. Raylib likes to draw rectangles in a particular way, different to the way that I do. Namely, I think raylib likes to specify a rectangle by a top left coordinate and then a width and a height. I rather specify rectangles with centers. So first of all, let's actually find out what the main raylib functions are. So yeah, if we do the raylib cheat sheet, which we can download as a PDF. Save that here. Oh no, I haven't, on this computer I haven't set up Sublime Sumatra PDF. Let's just quickly download that. I'm not using, I'm pretty sure Adobe's PDF reader is 10 gigabytes or something, which is just completely obscene. I just want something programmed by competent people, and that's not the space of 5 operating systems. Well, at least 5 operating systems a decade ago. Okay, this should be fine. Okay, see? Now, I'm pretty sure if you tried to download Adobe PDF Reader, it would take 10 minutes at least. That took less than a couple of seconds. Okay. So draw a rectangle is the binding we want to do. Okay, so let's let's see, what's a good, let's just draw any to begin with. So that's it, draw a rectangle, pos x, pos y, int and width. So let's say 100, 100, 500, and 500. And then the color, so let's make this gray, for example. That was a bit silly. So I can zoom this. Okay, rectangles are working. Very good. So, so now. Okay, so let's think about the position of these then. I guess later on we'll want to make the windows adjustable because I don't think they're currently adjustable. Let's see, if we go to It's really hot in winter. Yeah, like when I was using, I think like the GLFW bindings, you can very much make adjustable windows. I'll leave that later in raylib. Let's just actually get the main stuff working. Okay, so I want to have everything kind of center aligned. So let's define. Apologies for a sec. The heating in my house is really old, and so it's just super dry, so I just seem to be coughing. But now I've turned the heater down. Okay, so hopefully that should make things better. Okay, so let's do, let's make a, first of all, there's no reason for both of these to be not global, inside main. I feel like I'm gonna just have to like cut this down if I keep coughing. Okay. So then let's I think since we're doing stuff with screen positions and vectors, it makes the most sense to use these like vector types in Z. Yeah, while I'm gonna cough, I'm just gonna mute the sound, and then when I stop coughing, the sound will come back on again. Okay, my coughing fit seems to have ended, so we are back. I'm back. Let's just make this full screen again. So yeah, I don't like, when I'm trying to make things symmetrical, I find trying to draw rectangles with like the top left coordinate is infuriating. So let's just create a separate procedure to draw things in a centered way. This will just require us to, this will just be a procedure that calls the standard draw rectangle function, but that just means we need to do a conversion. So if we're given the center of a rectangle and the width and the height, and we want to calculate its top left coordinate, it's just going to be the position minus half of the width, and the top left y coordinate is just going to be the the y position minus half of the height. Since I'm pretty sure in raylib the standard is for stuff to be, the y-axis is flipped, but the x-axis is the same. There may actually not be a need to specify the type of this. We'll see. And then we just want to do the standard draw a rectangle. Now with the top left x, now with the top left y, and with the same width and height. Okay, so now let's I can feel the coughs coming back. Okay. So now let's actually call this new one, draw the centered rect, but now using our screen center, and now we'll make it 500 by 500. Okay, let's see what compiler errors we get. Okay, line 8. Okay, that was kind of obvious. Use of undeclared identifier screen width, line 21. Right, since we modified that. Okay. Type vector does not support field access. Are you serious? Okay, I guess this is how. Really? Like, this is going to be a bit annoying if this is the case. It won't be the end of the world. We'll just create a fixed array instead. Okay, does it... Okay, so like the .x field access doesn't work, but maybe this does. Again, one of the reasons I'm doing this is to learn Zig. So, oh yeah, we need to pass in what the color is. That's right. So color raylib dot color. Okay. So then let's make this gray. Expected I32 found F32. Why does draw rectangle want signed integers instead of floats? Like, come on. Okay. This is what it is. Let's just convert this. Windows, what are you doing? This is the Windows operating system, everyone. You just press buttons. You know, menus get drawn and you can't make them go away. So let's now, okay, we need to do these type conversions. I'm not familiar enough with Zig that I can just immediately write what these are. So we need to just convert, we want to convert these ones here into the nearest integers instead. So how do we do this again? It's like int, let's just do it the easiest way. How do I convert floats to ints in Zig? Let's just run the quick LLM, see if it doesn't do anything. Okay. Let's see if this works. Standard.math.cast. Okay. Let's do it up here. Let's just import what the standard library is. Okay, and let's just see if this itself made a difference. Okay, this class wants 2 arguments. Oh yeah, oops. Okay. I mean, if we're having to say what the type is in this class, presumably we don't need to specify the type to the compiler then. Reached unreachable code. That's always good. Okay. The LLM failed, so let's just go back to the Zig documentation. We could also actually check the Ziglings exercises to see if there's some examples of casting in there. Okay, let's go to documents, Zig, and see when castings appear in this. Not too many. Like I think I did like one of these in the exercises. I just forget. So maybe int cast is all we actually need. Oh, okay, here it is. Int from float. Okay, surely this is what we want. Okay, finally. Okay, int from float. Okay, and so if I tell the compiler I want that to be an I32, I want that to be an I32. Not there yet. Now what? Expected 1 argument found 2. Oh yeah. Expected type I32 found F32 on line 15. What? It wants the width and the height, or... Okay, fine, fine. I'm sure if you actually have a look at this, okay, indeed, all of these arguments are ints. Fine, but it's... I don't know. This feels like a weird raylib choice to make. But okay. I understand. Okay, finally, we finally got there. Okay, it only took the 20 compilation errors, but okay. We now know how to convert from floats to ints in SIG, and we know that, yeah, to more closely look at the documentation of raylib functions we're calling. Okay. Okay, so with this gray rectangle, then I kind of want this. Let's just like come up with some basic positions of where the images of the animal should be, and then where the text option buttons should be as well. Okay, so I kind of want 4 buttons, I think, arranged in a kind of square, like a 2x2 grid layout. So yeah, it will be useful to have. I think it'll be useful to the cost are nearly back. Instead of making the size of the buttons dependent on like the text in them, just to make it a multiple of the screen. Let's just say like button width is like a third of the screen, maybe. And then likewise we can just say the button height is 2 times the screen height. And then okay, time to put on something warm. And then okay, I guess we should probably define a distance between these buttons as well, and then we can just make we might want the vertical and the height difference between them as differences to be different. So we can say button spaces. Okay. So button. The button horizontal space. Let's make this 0. Yeah, we can make this 0.1 times the screen width, and then we can make the vertical space to be okay, let's actually make this 2 and make this 1. Okay. And look, wow, look, we're going to adjust this later, so let's just correctly describe what these are. But this will mean we'll need to replace a bunch of things. So whenever we see screen, let's replace this with initial screen. No. Yep. Oh! I got the rejects wrong. Replace screen with initial screen underscore. No, yes. Yep. Okay. Okay, and let's actually draw some of the buttons now. Draw yeah, text button backgrounds. Let's see, draw image. Okay, so then let's compute what the positions of these 4 buttons will be. So I think it would be good to group like, so we want this like 2 by 2 grid of buttons, and since we know all of the spaces and their widths now, if we knowing the center of where this button is, the center of this array will determine what all the others are. So we should compute what that is. So we can say button option, maybe like button grid center. Let's make this. I still find it really weird that like vector.x and vector.y doesn't work, but like vector.011 does. A bit weird, but let's continue on. So let's make this. What should we set this to? We want it to be center aligned, so okay. But it's going to. This one is going to be dynamic with the screen width, and so let's actually. We want the screen width to equal the initial screen width. Come on, initial screen width, and the screen height. Okay, to be the initial one. Okay, so we want these button centers to be centrally aligned here. Let's do this again. And then, where do we want, like vertically, what do we want this to be? Maybe we say this is 7/5 of this. Okay. So now we need to draw each of these actual rectangles. So, I think it makes sense just to draw this as an array, since all of the what I'm trying to do at the moment is just decide whether to, even though we're just drawing 4 rectangles, to put them in a loop or not, or just name them separately. I think it makes sense just to draw them as a loop. If for whatever reason we need to do like manual tweaking of things later, we can always expand it. It's fine. Okay, so now we want to say the button centers are going to be a fixed array of these F32 vectors, and what do we want them to be? We want these to be the button grid center y-x coordinate minus. Okay. Let's just define these centers one by one. It's going to be easy this way. So button kind of 1, 1 will be something. I'll just use matrix array notation for this. 2, 1, 2, 2. Okay, so now we have button, grid, center, 0. So the x-coordinate minus half of the spacing. And the spacing, what did we call this spacing again? Let's just move it up here. So the spacing is button horizontal space. And then from that, we also want to subtract half of the button width. And we'll likewise need to do a similar calculation for what the y coordinate of this one should be. And we're gonna draw this one afterwards just to make sure it works before we copy paste other ones. And then for the y coordinate, we now just want to subtract half of the vertical space from the center, and then half of the height. Okay, let's ignore this one, and then let's draw one of. Okay, let's define one of these. So we could say the button, that's 1, 1. The position of this is just yeah. And the button y, and then we need to do. No, let's just draw this using the draw centered rectangle command. And then we want the width of this, which is a constant, right? So now it's button width, button height, and then the color. So let's just make this gray again. Okay. Okay, let's see what compiler errors we have this time. Line 53. Oh, this should have been the curly parenthesis. Oh wait, I'm being silly. I meant to wrap it to like this. This initial screen height. I think it's because it should be like. I have this like weird habit of using this like width and height because I don't like the names being different. But the you see the consequence here. Oh come on. So this is line 14 now. Okay, yeah, since it's a variable, we need to tell the compiler what this should be. So we want this one to be an F32. Okay, and that looks alright. Like the bottom left rectangle here looks like it has been centered stuff. But I was expecting this to be the top left rectangle, not the bottom left rectangle. Okay, let's like ultimately, the names of these things are going to be randomized. So ultimately, this isn't actually that much of an issue, but it would be good just to know what was going on instead. It's something to do with the axes, but let's. If we draw if I draw what the top right button should be, I think this will give me would tell me what's going on with the axes. Okay. Okay. So if it's say it's the top right instead, then for the x coordinate we want to be adding the horizontal space and then adding half of the width, and likewise for the height though we want it to kind of be the same. And so this one here should be let's see, if we draw this one now, okay, get rid of that, rebuild it again. Okay, yeah, so it's the axes seem to be going from like the origin, so maybe the origin in raylib is the bottom left instead of the bottom right, unless I'm doing something really silly with these calculations. Yeah, okay, in either case, basically just want to duplicate these, but now make all of these the second columns instead, and we're now change the x positions are relatively the same, but the heights are changing, and so for the heights now, instead of subtracting this, we want to be adding it. I don't know why Emacs is slowing down. Like, come on, Emacs. Oh, okay. Oh, yeah, the compiler is rightly telling me that I haven't used these variables. So let's just draw them. Likewise, these ones here. Okay. Oh, come on, what's wrong now? Unused local constant. Line 53. Why is it complaining about the button width and button height? So it's saying 52 and 51. Oh, I see. It's just a copy pasta mistake. Both of these values here are the same as the ones as the line above. That was all. Okay. It's good that the compiler is good in this regard. It catches copy pasta mistakes. Okay, so actually the corners weren't flipped. It was just I was drawing the center too low. That's great to know. Okay. So now instead of drawing the center at that far down, if we make it a sixth of the way, for example. No, that's still not great. Oh, okay. Another copy pasta mistake. All of these are using the x coordinate of the center instead of the y. Okay, so maybe, what would be the best way to rearrange this? Come on. Okay, this is better. So now, yeah, I reckon actually if we move this to like a sixth of the way down, it might be okay. But I think also now that the bottom widths seem to be too large now. So let's reduce the height of the buttons and relatively move them down as well. And then let's see. Instead of these heights being 2, what if we made them like 1? Yeah, this looks a bit better. There seems to be a bit too much space between them now. So let's let's reduce this horizontal space a bit. Yeah, I think 1 actually would be fine. And then okay, now that that other bug is fixed, maybe 7's okay. And for this central rectangle, let's give this some coordinates as well. So we should say image center. We'll center align this as well, and then make this 0.3 of the screen height, and then we should really determine the widths of this. So the width of what the photos that we're going to draw are going to change. But maybe even though those may change, maybe we still want to fix the height and then just scale the rest. Like, I think if I was using it, I would prefer it if the buttons like remain. Sorry, so the problem is this. Say like the photo that we're going to have in the app is one of the photos looks like that and the other photo looks like that. If we decide to keep the proportions the same, the locations of the buttons are going to change depending on like when we advance through the questions, which I think is a bit annoying. I would prefer for the buttons to be fixed in place and then just for the height of the image to be fixed, but the width of the image can change. So then let's just say then that the image height is going to be a constant, and we'll make, well, a constant relative to the screen height, and then and yeah, and then the width of it, we'll adjust it when it's time to load the images. But for the moment, let's make it 500. Okay. Okay, this is already looking promising. I'm happy that we're already up to here. I kind of want the buttons to be a bit further down though. This looks like a bit too much space. So let's, where's the button center? Okay. We'll make that 7.5, and then I want the height here to be a bit larger. The 0.3 was not. doesn't look large enough. Okay. Okay, this is looking better. Okay, let's see. How are we going for time? We're nearly at an hour. Okay, I might do another half an hour. Okay. Okay, let's figure out. Okay, let's just save what we've done so far. And yeah, for everything on this channel, all of the code is going to be publicly accessible. So let me make a repository for this. Okay. I don't have any public repositories yet. I know. So let's make one. So good new. Let's call this. Yeah, like butterfly quiz. Yeah, it's public. Yeah, a basic quiz written from scratch in Z using raylib. Yeah, to help me learn names of a variety, names of various I think that's the plural for butterfly, but if not, too bad. Okay, and then no, we don't want to do that. We'll create a git ignore if we need to. Oh, okay, let's see. So I think a lot of the images we're going to find will just be from Wikipedia, Wikimedia Commons, these kind of things. I think a lot of them have like Creative Commons licenses, so I need to be careful not just to make this public domain if it contains stuff that's not public domain. What one should be used? Like the code itself should be, any of the code I write should be public domain. It's rather if the images of the project may not be. Maybe I just need to write a custom license instead of choosing one here. Okay, I think I'll end up doing that. Okay. That way we can just be super clear. There's no way I'm using GitHub Copilot. That could go away. Okay. So now let's yeah, this is the one we want to do. Okay, so we want to add. First of all, we want to set up a Git repo. Here. Ooh, and then I think we want to add everything, right? Or at least almost everything. Oh, okay, we want to add everything that's not in the Z cache, since the Z cache is, we don't want to save that. We also don't want to remember any of the temporary files as well. Okay, let's just create the git ignore then. So yeah, anything that ends with this, tilde, ignore, and anything which contains Z cache, also ignore. Yeah, that kind of looks what we want then. Yeah, okay. You've added another Git repository inside of. Oh yeah, this is correct. Let's just like delete the Git stuff from the one inside the raylib. We'll need to make a note, however, of the the version that we cloned. So get rid of that. Okay, now let's try. Okay. Fadeaway. Okay, wait. What's happening here? What's going wrong? Because the thing is, like, on my system, there's always problems with the submodule stuff, and I'm not I just try and avoid the submodules whenever possible. Okay, this seems to be working so far. But before we do this, let's just record the state of the previous this one here. So when we clone this, what was the commit number we got? Okay. This one here, copy. Let's add this into the project. Okay, so when we do this import raylib, we don't need to like transfer the entire commit. We can just say we directly copied some pre-existing raylib bindings by who is this? By not Nick GitHub user not Nick and others at okay, we do it here at here. And then we'll just say which one we committed. Yeah, we copied commit number this, and then we should also add in we should add in who we should also just make it clear to anyone who the original author of raylib was. What's this person's name again? I've forgotten. Just embarrassing considering I listened to a talk. It was like Ramos. If Ray doesn't have their full name here, then I guess that's fine. We can just call them Ray. Raylib, is created by GitHub user Ray at raysan5 and available at see the GitHub page for full license details. Okay. I can just say see the pages above. Okay. Okay. Now we've now we haven't committed any any thought crimes by copying stuff and not giving proper attribution. Let me just add everything again. I think we now should be ready to commit this. So now we can do. I don't think we've made any initial commits, right? Yeah. So we can just say made initial commit drew drew sort of basic button rectangles. Oh yeah, I'm gonna have to set some of this really basic stuff. Global user dot email. Let's see, loaded at metaverse dot net. And we can say config global user dot name loaded. Okay, let's try committing this again. Okay, great, that's done. Now we can actually push this to here. So that's right. So now we need to do git remote add. I'm not going to call it origin. Let's call it GitHub storage, since that's basically what it is. Then this position. Okay, and now we can do. I'm pretty sure like this already is the main branch, right? Yeah. So we need to do git push u GitHub storage main. It's going to want me to probably log in, since this is the first time I'm doing this. Yeah. Let's see. Sign in with my browser. Yeah. Yep. I kind of want that to happen. Okay. Okay. So then if I go back to here. Okay, great. The stuff we've done so far is on here. Very good. Okay. So now that's saved, we can, and this is public as well, right? Anyone watching this can just go this. I'll include all of these links whenever I upload this recording to YouTube. Just make sure it is still recording. Great. OBS sometimes has hiccups. Okay, we can go back to actually the fun part, which is programming and getting this stuff working. Okay, so we're here, and yeah, what? Oh, okay, and okay, we have like, I have like 15 minutes before I need to go. So what now? Why didn't we just get the mouse detection stuff working? So we'll just do it so that when the mouse is hovering over any one of these buttons, the button will change a different color. And then next time we can start adding some images in, or start figuring out the logic of like how to represent the data in this quiz in such a way that the screens will be advanced when the correct buttons are clicked and everything. Okay. Okay, so let's do mouse stuff. What are the raylib functions for mouse? I think we just want this like get mouse position, right? This one here. So this is just tiny for anyone who's watching this. I think this is what we want. We'll also want whether the mouse is pressed down or not. We'll start off with the position, and then once we get the position working, it will be straightforward to add in, is the mouse pressed, has the mouse been pressed down when, well, has the mouse been clicked in a given rectangle? Okay. So okay, what's the difference between this? Let's make this full screen. This get mouse position and get mouse delta. Okay, yeah, we're not when I'd be very hesitant to use a function like this, but okay, instead of just writing it myself. Okay, get mouse position void, and it's a vector 2, which won't be what Sig's using, so we need to think about this. Okay, how can we do that? So we can do. Let's just see what numbers get pushed out by this function. So we can do mouse input processing. So it was called what, get mouse position. And yeah, what should this be? This is a raylib vector 2, so I think that something like this should be okay. It's going to be a constant. So constant mouse raylib mouse pos is equal to this, and then let's just print it out and see what it looks like. So oh yeah, what's the standard print function again in Zig? Let's find this out. I'm just opening up these 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 Zig exercises. I find it's the easiest way to remember this stuff. So if you call print standard, okay, d print for debug print, standard debug dot print. I hope the costs are not coming back again. So now we just do dprint. How do these format strings work again? Mouse pause. I think that should be okay. Let's see. Nope. Doesn't like it. Oh, what? Why? Line 52. What's wrong here? Oh, we've got two equal signs, obviously. Okay, this seems to be working, right? I'm moving the mouse. These values are changing. So how does this work? Is this considered 0, 0? It looks like it. Oh, so maybe it's actually just outputting these results. Are these results floats? What are these? Okay, it's just whatever's in the vector 2 data type is what this is putting out. So yeah, I can see the x coordinate is changing positively as I increase it, from like 10 to the negative 3 over here. I mean 10 to the 3 over here, and then it is going down. Okay, so this is the origin. Okay, we want to convert these to like relative coordinates, so let's try dividing these by the screen width and the screen height, and see what that happens. Okay, so let's say we have mouse position the sensible way. So we want this to be a vector, and now it's going to be whatever the number raylib is outputting divided by the screen width. And then likewise, whatever this is outputting divided by the screen height. Yep, this. And let's see what this is now. Okay. So I want this. Operand must be a slice array tuple or vector. What's going on? Can I not access the first and the second entry in this vector too? Why on earth would this vector type not support indexing? This is ridiculous. I guess we can look into what this type actually is. This feels so silly. But okay. Let's see. It should be in this one, I think. Vector 2. I mean, come on, like, how can I not index this? Is this not just a standard struct? What's going on? Okay, I guess I just have to call this .x, which, okay, that's fine. That is a sensible way of doing it. Okay. Okay. This is more what I was expecting. Yeah. All of these numbers here look like, 9 times 10 to the negative 1. So basically like 0.998. Okay. So now we've got stuff that's actually going between 0 and 1 again. Okay. How are we going for time? Ooh. I am gonna have to head off basically now actually. Okay, I think this is a fine place to stop for next time. Let's just add in some to-dos then. Okay. First of all, label this as a debug since we don't want this happening in the actual app. So to do determine when the mouse is hovering over a button and register when it is clicked over a button too. Okay. Let's just move this at the top. And then where should we move this license thing? So we're going to say, yeah. So, like, presumably this Nicholas Whipper is the not Nick. So let's by sort of at GitHub handle not Nick. And others at this git handle. Okay. let's just make sure this is working again, then we'll commit the changes and then call it a day. Okay. Add. Let's make sure that I'm not committing anything that's weird. Great. Okay. Yeah, sort of like started adding mouse stuff. We can push this. Great. Okay. So that will be the stream, everyone, for tonight. But yeah, I plan to to regularly continue to build this over the next coming days. Yeah, I'm not going to set any like timelines or anything like that, but I'd be surprised if it takes more than like 20 sessions for this to be complete. Like this feels like a project that would take between 10 and 20 hours. But yeah, if you watched any part of this video, hope you learned something. But yeah, otherwise you can find all of these, I'm recording all of these streams. I'll put them up on a YouTube channel so that anyone who is interested in doing something similar or who wants to learn can try and learn from them. Okay, thanks everyone. Bye.